For thousands of years, the moon has inspired poets and storytellers alike. And for good reason. It's Earth's only natural satellite, aside from the occasional small rock that temporarily gets trapped in our orbit. But what would actually happen if the moon suddenly vanished? Could our planet survive? Could life go on? In the beginning, there was chaos. During the early formation of the solar system, there weren't just 8 planets. There were countless protoplanets, and they weren't traveling in the orderly orbits we see today. They were constantly colliding with one another, hurling enormous chunks of rock across the solar system. One of these protoplanets, thought to have been roughly the size of Mars and named Theia, slammed into Earth while our planet was still cooling. The impact sent enormous amounts of material flying into space. Pulled together by Earth's gravity, those fragments coalesced into a ring around our planet. And the moon was born from those very pieces of Earth. Poetic, isn't it? This formation process took approximately 30 million years. To put that in perspective, if we compressed Earth's entire 4.54 billion year existence into 24 hours, Earth would come into being at second zero. And the moon at the 10-minute mark. When the moon first formed, it was far closer to us than it is today. Only about 25,000 kilometers away. That's less than half the circumference of the Earth. Had the moon remained that close, it would appear roughly 15 times larger in our sky than it does now. But it would also exert a gravitational pull so intense that Earth's crust would experience violent tidal forces, driving surface temperatures to extremes that would make life on the surface impossible. Fortunately, that same gravitational interaction transfers a small amount of Earth's rotational energy to the moon with each tidal cycle, gradually pushing it into a higher orbit. As a result, the moon has been slowly drifting away from us ever since its formation. Laser measurements confirm it's moving away at a rate of about 3.78 centimeters per year. But let's set that gradual drift aside. What if the moon simply blinked out of existence right now? Would Earth crack and explode? No. At least not right away. The immediate effects wouldn't be dramatic at all. Our nights would simply grow darker, and we'd lose that stunning sight in the sky. We actually get a small taste of how dark a moonless night would be during a new moon phase. On the astronomical magnitude scale, where lower numbers indicate brighter objects, the sun sits at minus 26.7. A full moon comes in at around minus 12.74, making it roughly 12,500 times less bright. Without the moon entirely, our nights would be about 10 times darker than a new moon. That's not total blindness. You'd still be able to see. But some sources tend to exaggerate just how dark it would get. There's actually an upside. The Milky Way and even nearby galaxies like Andromeda would become dramatically more visible in the night sky. That said, many nocturnal animals would struggle. A large number of them rely on moonlight to hunt at night. Moths, for instance, are already confused by city lights. And without the moon, they'd lose yet another navigational cue, which could seriously disrupt their reproductive cycles. Sea turtles, after hatching, navigate by following the moon's reflection on the water's surface. As it stands, only about 1 in 1,000 hatchlings makes it to adulthood. Without the moon, those odds would drop even further. And a slow, silent extinction would quietly begin from day one. The more critical effects, however, would start appearing within just a few hours of the moon's disappearance. The moon's gravity currently holds the ocean's central regions roughly 40 centimeters higher than they would otherwise be. The moment the moon vanished, that mass of water would rapidly redistribute. This sudden gravitational shift could also cause fractures in Earth's crust, potentially triggering earthquakes or volcanic activity, though that's a lower probability outcome. More noticeably, the tides would change dramatically. The moon is responsible for roughly half to 2/3 of the tidal forces on Earth. The sun accounts for the rest. Without the moon, tidal ranges would drop by 50 to 67%. At first glance, smaller tides might just mean worse surfing. But tides are critical to coastal ecosystems. Crabs, mussels, starfish, and snails depend on the nutrients that tides break apart and deposit along shorelines. Take away those tides, and the food chains that depend on those organisms, both marine and terrestrial, would face intense resource competition. So even the short-term effects of losing the moon would seriously strain the food web in the medium term. But the most consequential long-term effect would be on Earth's axial tilt. Right now, Earth is tilted at approximately 23.4 degrees relative to the plane of the solar system, and the moon plays a key role in keeping that tilt relatively stable. Earth's tilt does vary naturally, oscillating between about 22.1 and 24.5 degrees over cycles of roughly 41,000 years. But without the moon as a stabilizing force, that wobble would grow increasingly erratic. Most of Earth's surface would eventually be buried under massive ice sheets, except for a narrow band near the equator. We see something similar on Mars. Its moons are too small to stabilize it, and its axial tilt is calculated to swing between 0 and 60 degrees over millions of years, causing its surface conditions to swing between one extreme and the other, season after season. Up to this point, I've been talking about what would happen if the moon disappeared today. But we can also consider what would have happened if it had vanished, or never formed, much earlier in Earth's history. Earth's rotation would never have slowed to its current 24-hour day. Depending on the assumptions you make, a day on Earth might have been as short as 4 hours. That rotation change alone would have had enormous consequences for life on Earth. But I'll save that for another video. If you enjoy this kind of content, make sure to turn on channel notifications. One of the most debated effects of the moon's disappearance is whether it would change Earth's orbit around the sun. As I mentioned earlier, the moon doesn't orbit Earth, and Earth doesn't orbit the moon. Both orbit a common center of mass called the barycenter. Because Earth is 81 times more massive than the moon, that barycenter lies very close to Earth's center, specifically 4,641 kilometers from Earth's core, which is well within Earth's radius of 6,371 kilometers. This is why Earth wobbles slightly as it moves around the sun. If the moon disappeared, that barycenter would shift almost to Earth's center, slightly altering Earth's average orbital velocity. Calculations show this change could increase or decrease Earth's orbital speed by about 0.01%, depending on where in its orbit the moon was when it vanished. In orbital mechanics, a change in speed corresponds to a change in orbital altitude. So Earth's orbit around the sun would shift slightly. But this would be an incredibly small change. After all, Earth already swings between about 147.5 million and 152 million kilometers from the sun over the course of a year, a difference of 4.5 million kilometers. Naturally, many simulations actually show the moon's disappearance having no measurable effect on Earth's orbit at all. In theory, however, depending on the moon's position at the moment of vanishing, the shift in gravitational forces could make Earth's orbit slightly more circular or slightly more elliptical. Either way, this effect would be minor compared to everything else discussed here, and it would take millions of years to produce any meaningful change. To really understand why it takes millions of years, I'd love to walk you through the famous three-body problem in physics. But we don't have time in this video, so let's save that for another one. Finally, the moon's disappearance would have sociological effects as well. Darker nights would likely lead to higher crime rates. Scientific progress would also take a hit. Earth's active tectonic processes have melted and destroyed most of our planet's ancient rock records. But the moon, being tectonically quiet, preserves rock samples dating back 4.45 billion years. Those are, quite literally, pieces of the early Earth, frozen in time. Studying the moon allows us to read our own planet's history. Without it, those records would be gone. And the sheer force required to knock the moon out of orbit would trigger mass panic. To put it in perspective, imagine a 1 megaton hydrogen bomb. Now imagine detonating one every single second, without pause, for 288,000 years. Whatever could generate that kind of energy, whether a mindless phenomenon like a black hole or an intelligent civilization capable of wielding it, is something that should spark your imagination. Now, everything I've described so far represents the classic, popular science version of what we'd expect if the moon disappeared. But some of these effects tend to get exaggerated in certain sources. For example, we said losing the moon would send Earth's axial tilt into chaos. But some models suggest that Jupiter's gravity alone could eventually stabilize it. We said nocturnal predators would struggle. True, but their prey would gain a massive advantage. Telling only the catastrophic side makes for great clickbait, but it doesn't reflect the full picture. One claim that's especially overblown is that the moon protects Earth from meteor impacts. The moon orbits 380,000 kilometers away and has a diameter of only 7,000 kilometers. The sky spans roughly 41,253 square degrees in all directions, and the moon covers only about 0.25 of those square degrees. I'll talk about Lagrange points in a future video. Those are special gravitational balance points, like the L2, where the James Webb Space Telescope is parked. But the Moon-Earth system's Lagrange points are weak and small, nothing like the powerful shield effect of a massive body like Jupiter. In short, the Moon's ability to protect Earth from meteors is negligibly small. In fact, it's more likely to deflect an asteroid that wasn't on a collision course and accidentally send it toward us. But the Moon protects us from meteors. Sounds cool, so it keeps getting repeated. Yes, losing the moon could shake food chains and push species toward extinction. But life on Earth has survived events far more catastrophic than this, dozens of times over. Life always finds a way. That doesn't mean life is invincible. There could be something that wipes it out entirely. Our existence carries no guarantees. But we need to understand that not every disaster scenario means the end of Earth or the end of life. The loss of the moon would have serious consequences, yes, but most of those effects would unfold gradually and slowly. Many would only manifest over the medium to long term. The idea that life would simply be wiped out the moment the moon disappeared doesn't hold up. On the contrary, as I said, life has adapted to events far more destructive than this. Through the mechanisms of evolution, it would likely adapt to a moonless world too. And carry on. We believe the conditions we live in now are the best possible conditions because we've only ever known a world with the moon. But it's entirely possible to imagine planets far better suited for diverse and lasting life without any moon at all. So I'd caution against placing too much weight on, if X had been different, everything would have been terrible narratives. Without seeing the full spectrum of possibilities, we can't conclude that what currently exists is the only viable option, or the best one. As of the day this video was made, we've identified only about 4,980 exoplanets around the trillions upon trillions of stars in the universe. A number so small, it's almost laughably precise. Our understanding of what's possible out there remains profoundly limited. Who knows what's waiting for us out there? See you in the next video. Take care.